स्टार्ट करना है गेस. Hello, am I audible? If I'm audible, put it in the chat, please. Yeah, we'll wait 5 minutes for people to join. We'll start around 8:05. Okay, then I guess let's start. Let's start with an introduction. I'm Aditya Devdeshmukh and I'm a part of CodeChef-VIT chapter at VIT Vellore. And today I want to give you an introduction to Opencv and how to do image manipulation. So what exactly is Opencv? So Opencv is an image processing library which is available in a lot of languages like C++, Python, Java, MATLAB, and many others. So some of its features would include image manipulation. So let's say you have an image and you want to read it and then you want to increase its brightness, contrast, or something like that. Then you can do this in Opencv. You also have object and feature detection. So let's say you have some sort of robot that wants to maneuver its way around some terrain. and it wants to detect some obstacles that it might face. So you can do that in OpenCV. You can have pattern detection. So let's say, in case you want to make a security system where it detects pattern of other people, then you can do that. Then there is video analysis. You can capture video from your webcam and then feed it into OpenCV. So if you want to run, let's say, a mask detection system, during recent times, so you can do that in OpenCV. So some of its uses would be like in robotics. You can use it for location detection and obstacle detection, as I mentioned. It can be used in navigation or assembly in industry for assembly. So if you want to assemble, let's say, a car, and you want your robots to be able to view what is going on inside, then you can use OpenCV with the use of a camera to detect some irregularities or something like that. It can be used in medicine for cancer detection. So let's say you have an MRI. It can, with the help of OpenCV, you can feed the MRI images into OpenCV and train a model so that you can detect these cancer cells. For security, you can use it for biometrics such as face, fingerprint, and iris recognition. So you can train a model to detect the fingerprint of a certain person. And for surveillance, it can be used in transportation for autonomous vehicles. So it can be used for detection of pedestrians and other obstacles. It can also be used for detecting how drowsy a driver is and how vigilant he is. So OpenCV has some competitors when it comes to Python. So there are two main libraries in Python. One is OpenCV and one is PIL, or Python Image Library. So there are some subtle differences between these two libraries. The first one, OpenCV, it's a library written in C and C++, whereas Python PIL is written in Python and C. Due to it being written in C and C++, OpenCV tends to run faster than PIL. Now, another minor difference is OpenCV reads images in BGR format, whereas PIL reads in RGB. This is because when it was written, usually camera companies used to have BGR format. So that's why it was more popular that time. So basically, how does OpenCV work? What OpenCV does is it'll read an image inside your system and then convert it into a matrix. So as you can see, this image, the first one, let's assume that it has 4 pixels, two in the first row and two in the second row. Now what OpenCV will do while reading is it will convert these pixel color value to a BGR value and then store it as a matrix. Now there are mainly two types of images, right? JPEG and PNG. Now for PNG, you have to also store the transparency value of these images. So another value can be added to it, which is called the alpha channel. And this fourth value stores the alpha value of the image. So now basically, if you want to change the properties of some images, what you can do is you can change the values inside these matrices by your own functions or some functions provided inside OpenCV to change the image in certain ways. So here are some OpenCV references that you can refer. This is the documentation, this is the tutorial, and some useful websites. So now, once you're done with that, now let's move on to the demonstration part of it. Okay, so first of all, for OpenCV, you'll need to install the Python package for OpenCV. So for that, you have to basically go into your terminal and then type pip3 install OpenCV Python. And once you're done with that, once you're done with that, you can you can start coding in OpenCV. So now, firstly, I will import the OpenCV package. So for that, you have to type import cv2. We also need numpy in this. Import numpy as np. When you install OpenCV, numpy is installed by default. So don't worry about installing numpy. So okay, the first task we have is we have to read the image. So for reading the image, I can define a variable called img, which is the image variable, is equal to cv2.imread, and then you type the image address. So since it's in the same directory, I can type icecream.jpg, and then you need to type another variable. So this variable will define how it is inputted. So if you have it 0, then it will input it as a grayscale, but as 1, it will not change anything. Okay, so now I'll show you how it looks as a matrix. So let's run this. So here, as you can see, this will print a matrix of whatever values it has recovered from that image. So okay, now we have read it, but how do you display the image? So to display the image, you write cv2 dot imshow. Then you write what you want to name the window as. So I'll just show my image, and then you give the variable name. Let's run this. Oh yeah, I forgot a key factor. After that, you have to first type this cv2 dot wait key 0. This will do is this will wait for an indefinite time. uh, it's basically like an infinite for loop, and it will wait for a keyboard key to be pressed, and then you type cv2 dot destroy all windows. Now this will basically eliminate all windows that are there open of cv2. So as you can see, this is my image, but this I think is too big for my screen. So what I'll have to do is I'll have to resize this image and make it smaller. So now for that, there is a function called cv2.resize. Then you pass the image value, and then you pass whatever value you want it to be. So let's say I want it to be 400 by 600, the image. So now let's try and run this. Okay, wait. What's wrong here? Oh, sorry. Yeah. Oh, I forgot this. ing is equal to cv2. Yeah, now you can see it has resized this image, but it's like squashed because it doesn't understand how to compress the image that way. So instead of setting a standard value, it's much better that you compress it by a factor. So for that, what you can do is you can just write 0 comma 0 and then put another variable. Now you can write fx is equal to 0.2 comma fy is equal to 0.2. What this will do is this will compress the x direction by 0.2 amount and compress the y direction by 0.2 amount. So let's run this. Yeah. So as you can see, it has maintained the original ratio of the image. So okay, that's resizing and all. But what if I want to, let's say, increase the brightness or the contrast of the image? So for that, what you do is img is equal to cv2 dot add weighted. Now what this will do is this will take two images and then combine it into one by a certain rule. So I'll show you first how to do it, and then we'll explore it. First, you give the image file you want to increase the brightness of. Then you give how much you want to increase the contrast by. So I want to increase it by 1.2. So it multiplies it by that. So 1.2 times the contrast. Then I'll be using this function np.zeros img.shape, comma, img.dtype. I'll explain in a bit what this function does. And any value is fine here. I'll put it as 1 and I'll put this as 20. Yeah, as you can see, it has increased the brightness of the image. So we'll do one thing. We'll put it as something, put this as something else, edited image. And then we'll show edited image. And we'll also show cv2.im show first image, comma, im. Let's compare how these images are. So yeah, this was the original image and this is the brighter image. So as you can see, it has made the image brighter and a bit contrasty by increasing the amount of values by which you multiply the pixels by. So now let's see how this works. So basically what this function does is it'll create an array of zeros with shape as img. So it has the same shape as this image variable and the same data types as this image variable. So essentially it's creating a pure black image. So let's see it here. Dot zeros img dot shape, comma, img dot dtype. Yeah, see, it's creating a pure black image. Now what this function is doing is it's adding img plus the zeros, the pure black in a certain way. So what it's doing is img into alpha plus pure black into beta plus gamma. Now the 1.2 value is the alpha value. The beta value is 1 and the gamma factor is 20. Now since all this pure black is basically 0, when whatever you multiply it by, it will just add 0. So to increase the brightness, what you can do is you can set the second image as pure black. So this factor will just go out and you will be left with alpha plus image into alpha plus gamma. So this is how you increase the brightness and contrast of the image. Now another thing you can do is you can add various blurs to the image. So if you, let's say you want to blur an image, so what you can do is there are various types of blurs. I'll show you how to add Gaussian blur to it. So let's say blurred image is equal to cv2 dot Gaussian blur. Then you put the image value in it. Then you put the pixel values. You want how many pixels you wanted to blur. Yeah, and then 0. Now let's show this image. Comma. Now let's say. Yeah, see, it has blurred the image a little bit. Let's compare it to the original image. cv2.im show original image, comma, img. Yeah, as you can see, this image is crystal clear, but there is a bit of blur in this image. So there are various types of blurs. You can also have median blur. Then there is Gaussian blur, of course. And there's also a normal blur. cv2.blur. So okay, now that we are done with it, let's get to the interesting part of this. So let's say you want to detect a face in the image. So what do you do in that case? So for that, we have to use something called Har Cascades. One sec. Yeah. Okay. So I'll change the picture. So basically, Har Cascades are pre-trained models that will detect whether a face is present in an image or not. So we type face cascade is equal to cv2 dot cascade classifier. Then you have to essentially put path uh, the path of the XML file that you want the cascade, of which you want the cascade. So that path will be cv2 dot data dot har cascades plus. So for this we need the face, right? So I'll press har cascade underscore frontal face, sorry, underscore default dot xml, and I'll also add an I cascade is equal to cv2 dot cascade classifier cv2 dot data dot har cascades plus. Now for this it is har cascade underscore I dot xml. Okay. Now these two variables will have the cascade value of all of the frontal face and the eye. So now what we want to do is we want to see whether see whether your image has faces or eyes in it. So for that, what you can do is face is equal to face cascade dot detect multi state, and then you have to pass some variables to it. So these variables are okay. First, before that, you have to first convert your face to a grayscale image. So face, let's put it as face gray. Now face gray is cv2 dot cvt color. Now what this will do is this will change your face. This will change your image into some various types. So you can change it to your BGR to RGB if you want to, display the image in PIL. So I just want to convert it from BGR to gray. So what I'll do is I'll put image, comma, cv2 dot color underscore BGR to GRAY. Great. Yeah. Now what this will do is this will convert the entire image into a gray image and put it in the variable gray. So now what we have to do is we have to pass this gray variable into the face cascade. It won't accept your original image. So you first pass the gray, then you pass a value. So this value will determine how accurate your face detection is. So if this value is high, the accuracy of the face detection will be low, but it will take lesser time. The lower the value, the more the accuracy, but more is the computational time that it will take. And then you have another variable called the minimum neighbors. I'll just set it at 5. So what minimum neighbors does is so basically how this function works is it'll signal some pixels as faces. So now what you can set this minimum value is So this minimum value, minimum neighbors, will set the minimum number of pixels that should be in a neighborhood to call that a face. So if there is a small rectangle which it is detecting as a face, it might not actually be a face. So by setting this number to a high value, it will make sure that you have a higher quality detection. And setting this to a lower value will mean you will have less false negatives. Okay. So yeah. So now what this will return is this will return a tuple. So now what you can do is for x, comma y, comma w, comma h in faces. Let's keep it as faces. Now what this will return is this will return the x value, y value, width, and height of the face. Oops. Width, comma height. So now you have stored the x, y, width, and height of the face. So now let's draw a rectangle around it. cv2.rectangle. So to draw a rectangle, first you pass the image, img, comma. Then you pass the x and y coordinate of where you want the rectangle to start. So here I'll start it at x, comma y. Okay. So now you want to this tuple will set which is the other point. So you have to give two diagonal points. So the other diagonal point will be x plus w, comma y plus h, right? Then you want to pass a tuple of what color you want the rectangle to be. So I'll just put some random value 1, 2, 3, comma 45, comma 54. Let's see what color that gives. And then you want to give the thickness of the rectangle. I'll just say 3. I want the rectangle to be 3 thickness. All right. Okay. So now let's see how it looks. Yeah. Image. Okay, wait, what happened here? Oh, I didn't mean to resize it. Yeah. I don't want to resize this one. Fine. So as you can see, it has detected a face here. And now that face can be seen here. Okay. Cool. So now let's detect the eyes. So to detect the eyes, we know that eyes will be only in the face. So what we can do is instead of detecting eyes in the entire image, we can just say ROI, region of interest, is equal to then what we want to do is we want to splice this image so that only the part of the image which has the face is seen. IMG at, so we start from y and then go till y plus h, comma x to x plus w. So this is because for in CV2, whenever we have a excuse me, in CV2 when we have a matrix, it first references the row and then the column. So the row will correspond to the y variable. So we have to put the y variable first, and then okay, let's first see how it ROI looks. ROI. Yeah, as you can see, it just gives me the face. All right. Cool. So now I want to also pass the gray variable. So R gray ROI is equal to gray and same one y plus h, comma x plus w. All right. Okay. Now, what you want to do is you want to detect the eyes in this image. So what you do is the same thing which we did with faces, is equal to I cascade dot detect multi scale. Then you want to pass gray ROI. Then you want to pass the value which you want to pass, and then yeah. Then for, let's name it EX, EY, EW, EH in I. So now what we can do is we can again draw a rectangle in this. CV2 dot rectangle. CV2 dot rectangle. Then you want to pass ROI underscore color. Okay. You can just pass the image, that's also fine. Image, comma, ex, comma, ey, comma, ex plus w, comma, ey plus eh. Okay. And then you want to pass the color. So let's pass 25, comma, 56, comma, 234. Yeah, that should be fine. Yeah. Yeah. Let's see how it works. Oh, sorry. Image. Okay, yeah. As you can see, it has detected something else in the ear. Let me see what's the problem. Oh, okay, okay. No, you can't do this. You can't do this. You have to set ROI, and then you have to splice this image and put it inside image. So then you have img at y plus y, comma, y plus h. Oh, sorry, y colon y plus h, comma, x colon x plus w is equal to ROI. Okay, cool. Yeah, now let's see how it looks like. Right. Yeah, so now as you can see, the image has detected the face clearly and has also detected the eyes clearly. So that's a success. That's nice. Okay. So now what I guess we can do is, let's say we want to build a system which will blur out the images of people, faces of people. So let's say we are working for Google Street and we want to use OpenCV to blur out the faces of people we capture. So for that, what we can do is, first of all, we won't need this part. So let's comment it out. Yeah. So now I guess we will just comment out this whole thing. Yeah. So, and this also. Yeah. Okay. So now what we want to do is we just want to blur out this, the face of the image. So what we can do is ROI. I guess we need that. This one, this part. So to blur out, we can use CV2 dot. Let's use median blur this time. Median blur. Okay. So first you pass the image, img. Then you pass how much you want to blur it. So let's say 10 blur value. All right. So now let's see how ROI looks. Okay, 1 second. Oh yeah, it has to be an odd value. Yeah, it has blurred it a little bit. So let's see how it looks in the image. So first we'll have to splice out the image. Okay. No, sorry, ROI here. I don't think it has blurred out. 1 second. Yeah, now it has blurred out the entire image. Okay, 1 second. Oh, okay. ROI. Yeah. So we have spliced it and then we are blurring it. Yeah. Yeah. Now as you can see, it has blurred out the face. So now we need to splice it back into the image. So for that, what you do is img at y plus h, comma x plus w is equal to ROI. Now what this will do is it will take the blurred image and then put it back into the original place. Oh, sorry, I need to print image. I need to print image here. ING. Yeah, now as you can see, it has blurred out the face of the person. So in case there are like a lot of people, so let's try this with a crowd. CROWD. And let's also show the original image, I guess. So let's make a copy of this image. Image one is equal to ING. Now dot IN show, comma ING1. Right? Cool. Yeah. Wait, where is the other one? Yeah, so now you can see these images are blurred. Why is it not showing? Oh, okay, yeah, I know why it's not showing the problem. I know the problem. I don't know how to fix it. Oh. Okay, never mind. Yeah, it's okay. I guess we can also, we'll just read it separately. Let's try that. Let's just read it separately here. ce2.im read img1 count.jpg img1 comma 1. So why is it only showing one of them? Okay, never mind that now. I don't know what error it's showing. Let's try this. Maybe it's, yeah. Okay, now it's showing. So as you can see, these images, these faces have been blurred here. So it's not perfect, but it's good enough, I guess. So if you want to build a better model, then you can build something better than the Har Cascades. And see, this is the original image and this is the previous image. Okay, so let's have a recap. So firstly, we figured out how to read the image in CV2. Then we figured out how to resize the image with cv2.resize. Then we figured out how to resize the image by a factor. After that, we figured out how to increase the brightness and contrast of the image. Then we moved on to blurring of the image, and then we moved on to the advanced concept of detecting faces and eyes in the image. So I guess that's it, and I wish you all a very good night and happy coding.